All right, my SD card died, so I'm gonna pick it up here. I was just discussing that I'm gonna pick something to the left of my critical number. I'm going with pi over 6, which is 30 degrees. And remember, we plug that into the first derivative. We're trying to figure out if the derivative is positive or negative to determine the behavior of the function. So here I go, I'm gonna do pi over 6. I'm gonna plug this in here. Now, some people with this one might sort of observe it has a particular odd behavior, and they might notice that you're going to notice it's going to have an interesting answer. I just don't want to give it away if a student doesn't notice this. I want to just work through the process. And it's okay if you don't notice, don't worry. That's why we're in the class, right? We're trying to learn this. So 30 degrees is always across from a 1. 60 degrees is always across from a radical 3. And the hypotenuse is a 2 on this one. Okay. So we're going to do 1 minus 2 times the cosine of 30, which is radical 3 over 2. And the 2 and the 2 will cancel, so it's 1 minus radical 3. Radical 3 is about 1.7, so this is going to be negative 0.7 approximately, okay? So that means that when I put this in, that means that when I test pi over 6, I'm getting a negative answer. So that's telling me that the function's going down on that interval. All right, now I'm going to pick something in here. I'm going with something easy. So I'm going to go with like pi, because pi is equivalent to 180 degrees, which falls between 60 and, let's see, this is pi over 360. This is 300 degrees if you guys need this in... that's a little easier for you to understand. So this falls between, 180 falls between 60 and 300. You could pick anything. I'm just trying to go for what I think is easy to calculate. All right, so now I'm going to plug that into the derivative. So I'm doing pi, or 180. Okay, so you got the double negative, which makes the positive. So this is going to output a 3. All right, so we're going to get a 3 here. So it doesn't matter what the value is. What matters is that it's positive. Okay, so we get that. All right, let's pick something over here. I'm going to do short pi over 6. So 11 pi over 6. I'm going to go with, let me just write that as a degree for those of you who prefer it that way. That's 330. Okay, 330 I'm going with. All right, so here we go. 11 pi over 6. Up. Hold on, getting squeezed in here. Okay, so we got 1 minus. Now, I'll just write out the trig because some of you it helps for me to just like review the pre-calc a little bit as we go through this. So 11 pi over 6 rotates to here. But remember, you're using the reference angle, which is pi over 6, so you're in here. And how we figured out it was pi over 6 is you did 2 pi minus your angle, which is 11 pi over 6, which is ended up as pi over 6. Right, because you're trying to figure out, you didn't make it all the way around, you were short. You made it to 11 pi over 6, so you needed 1 more pi over 6 to finish this. So across from pi over 6 is always the 1. This one's radical 3, this is 2. So the across from the 30 is the 1, across from the 60 is the radical 3, the hypotenuse is a 2. All right, so it's a combination of being in quadrant 4, which makes it positive. I'm just going to stress this because you need the sign. You need to always think about the sign. You're in quadrant 4, so the cosine is positive. And then the cosine of 11 pi over 6, which is going to be this plus its sign change, or same. Signs happens to be the same here. So cosine of this is this over this. So radical 3. I'll fix it. I can see I have a... You guys know me, it takes me a minute, but I usually can see it. I can see I don't have the 2. I can hear you guys telling me, you don't have the 2 there. Okay, right, and I need the 2 there. And again, that's 1.7-ish. It's around there. All right, so this is going to be negative. So what matters is that this was negative. It's coming down. Okay, great. So let's start writing out the answer to part B now. All right, here we go. Part B, you want to say where the function is increasing or decreasing, right? So when we're going to look at our nice chart here, when we do that, so part B, so f of x, remember this is telling you about the original. Just like if you might reference somebody like, oh, they like to wear red clothes, oh, they have brown hair. Like you're talking about characteristics that describe the original person, okay? So this is describing the original function. This is describing a characteristic of the original function. Okay, so let's say f of x is increasing. So this tells me that the function itself is increasing from pi over 3 to 5 pi over 3. And that the function is decreasing from 0 to pi over 3 and 5 pi over 3 to 2 pi. Okay, so that's the increasing and decreasing behavior. That's answer to part B. So now let's do part C. So part C is your relative extrema. That's where you're going to use your first derivative test. So if the function is increasing, critical number decreasing, that makes a max. If the function is decreasing, critical number increasing, that makes a min. All right, so here we go. At every critical number, we look to the left and the right of it. All right, so on this critical number, the left side goes down, the right side goes up. So here at this critical number, we have a minimum. So I have a relative minimum at pi over 3. And remember, you don't plug this value now into the derivative. You know that the derivative is zero here. It's not the derivative. We want to find the height on the graph. So I'll come back to this. We're looking for this xy value. You know, actually, maybe let me do it now. So the original function again is this, the original, not the derivative, the original. I'm trying to find the height on the original. So I'm going to plug in pi over 3 into the original. All right, let me just do it now so I can be consistent. Yeah, I love my triangles. Okay, here we go. 60 degrees, 30 degrees, radical 3, 1, 2. All right, so this is going to be pi over 3 minus 2 times the sine of pi over, the sine is 60, so opposite over hypotenuse. Just depends, radical 3. Just depends if you want to get an LCD or not. If you get an LCD, So that is my... Now, if I was graphing this, I'd plug this in my calculator and approximate it so I get the right height on my graph. Okay, nice. So that's my XY value. Excuse me. Okay, so that's the height of the first one. And again, if we were graphing that, we'd just approximate that with our calculator. All right, let's continue back now. Now you find the other critical number, you look to the left of it. To the left of it, it's going up. To the right of it, it's going down. Right, we're doing the first derivative test. The slope goes up. We hit the critical number, the slope goes down. So that's going to make a maximum. So we have a maximum at 5 pi over 3. Now, as you recall from what I just did here, that we're looking for the height on the graph. The derivative at this point equals to 0. I'm not asking that. I'm asking what's the height on the graph of this. So now, just like we did before, you plug in to the original function to find the height on the graph. What am I doing? Hold on a second. The hand and the brain are having different conversations. We're plugging in 5 pi over 3 into the function. All right, so that would be 5 pi over 3 minus 2 sine of 5 pi over 3. Okay. All right, 5 pi over 3 is here. Means the reference angle is pi over 3. So the sine value, I can hear you guys saying it. Professor Whelan, where's that 2? And you'd be absolutely right. There it is. There's that 2. All right, so just don't forget when you evaluate this, you're in quadrant 4. And the sine... right, the big angle coming all the way around is the 5 pi over 3. The reference angle for 5 pi over 3 is pi over 3. All right, so you're in quadrant 4, which means the sine of an angle in quadrant 4 is negative, and we're going to use the reference angle, so pi over 360. This is across from radical 3. This is your 1 and this is your 2. Okay, so the sine of this will be radical 3 over 2. You'll notice the symmetry. You probably had a sense of that. Okay, 3, negative, negative, positive, radical 3. Again, if you want to do... let me do that a little better. Okay. If you want to do an LCD, you're going to get that. So let's just go back now and write this up here. 5 pi plus 3 over radical 3. So I think between the last video and this video, this might have taken me about 25 minutes to solve one of these questions. Right, so we're sort of entered the stage of mathematics where your answer is 3 pages long, but we did it. We got it. So congrats. I hope this helped. I'll catch you guys in another video. Bye-bye.